Hi guys, welcome back. This is the final section of the GameKeeper project. This is the snake activity. So this one is quite a lot more detailed than the previous three, the one about the decryptor and texting and everything. And that's because we're going to look at a lot of stuff to do with the programming paradigms. We're going to create our own classes in order to be able to make this project work. So what that means is creating a class is like creating a blueprint or an idea on how you're going to incorporate something into your project. So the idea of a button doesn't need to be created in Visual Studio because all we have to do is click on the toolbox and choose the types of objects that we want to put on. So the concept or the class of a button already exists, okay? But we need to create some of our new ones in order to make our project work for Snake. So for those that are familiar, Snake is a very simple old concept game where it's a simple little circle that moves around the screen, and every time that little circle comes into contact with another circle, the original one will grow. So the idea is that you start off as the snake head, you find a little piece of food, and then your body becomes a bit longer. Then another piece of food appears, and you've got to try and grab that one. Then you get another, the body becomes longer. Grab another piece of food, the body becomes longer, and the process keeps repeating until eventually you've got a snake that is so long moving around your screen that it becomes very difficult. You don't want to crash into the snake, you don't want to crash into the sides of the walls, all that sort of stuff. Okay, but in order to do that, we need to create the concept of that single circle so that we can use that circle in lots of different ways. And today what we're going to do is we're going to make it so that the circle is used as the food pellet, a circle is used as the head of the snake, and a circle is used for each additional body part. So we need to create a circle concept or the circle class. Okay, so you can see up the top, I've already opened up my tabs. You can see them down here as well. I've got input, settings, and circle. You don't need to worry about the program class. That's the one that comes default or built in when you first create it. So the first one we're going to start on today is the circle. So this is the project I'm going to be working on, but I'm going to jump ahead to my circle class. Now you can see that there's not a lot of particular code in this one. It simply creates the idea of a class called circle. Now these are important terms that you're going to start to get to know as you build in your understanding of programming paradigms. When we're talking about instantiating a class, it means that just generally the creation of a new class. Okay, then we've got to come up with the properties where we'll talk about the methods and the attributes and all that kind of stuff later on. Okay, so there are two properties that we're going to first create, and here they are now. So I've got one property that I'm going to call the x integer, where we're going to be able to retrieve that piece of data, and we're going to be able to set that piece of data. And I'm sure I used the wrong brackets then, my mistake. Okay, so I've got public int x, get, and set. So remember, we're not really creating the ability to retrieve data yet, or we're not processing the data. We're actually making it so that the data exists for us to get and to set. Okay, and then the next one is we've created an x property. We also want to create a y property. Okay, so I've got an x coordinate and a y coordinate. Now it's pretty straightforward. Basically, once we get into the concept, I want to create it so that x starts out as 0 and y also the same, so that I've got a 0, 0 circle by default. Okay, and that's actually all you need to do for the circle class. So we're going to jump ahead now and get to our next one, which is our input. Okay, so I'm just going to tab that one, move across so you can keep up with me. So I've got internal class input. So now what I'm going to do is I've created the idea of a circle. It has an x and a y coordinate. That's all I've done. I haven't used the circle anywhere. I haven't told it where it's going to go or what it's for. I just created it as an idea. All right, so now what I need to do is I need to create the concept that I can accept input to control that class. So what I want to do is I want to make it so that my up, down, left, and right keys are used to control the snake. So I need to create that concept that I'm going to be able to use those. So under my internal class input, we're going to first load the list of available keyboard buttons. Okay, so to do that, I don't know why that was just in caps then, we're going to create a private static function, and what you need to do is use this thing called the hash table. Okay, so as you can see on the screen, it says represents a collection of key value pairs that are organized based on the hash code of the key. So these are things that you can look up online. So rather, the up key, the L key, the space key, they all have equivalent codes. I'm going to give you them as we move down. But if you ever need to make your own game that uses a hash table, that uses input commands, you want to use the letter E to do something, then you'll need to incorporate something like this. Okay, so I've got the hash table, and I'm going to call it my key table, and it's going to be the instantiation of that hash table, as I said. Okay, scroll down a little bit. All right, now we're going to do create the idea. Like, is this button being pressed? So we're going to create this as a Boolean command. Did a button get pressed? Not what button got pressed. Was a button pressed, and is it a button that exists in our hash table? Okay, so pretty straightforward concept. Now let's go public, because this needs to be something open to everybody, and it's going to be a Boolean. So a Boolean class key pressed. Oops. Okay. Okay. I'm going to open that up. I might just. It's created those brackets just there, but I'm going to move that a bit further down because all of these comments that I've created for you there already need to occur inside that bracket. So what I want to do is I want to have that just down here. So I'm just going to get rid of that one. Right, let's move that one back across. All right. Okay, so now what I've got is if a key doesn't exist, is pressed, perform no action. So if we use a key that doesn't exist, we don't want anything to happen. Okay, so what I'm going to do now, let's create an if command. If key table null, so nothing. If it equal, sorry, not key table null. We want key. If the key that was pressed is equal to null. So basically, if there's nothing in it, if we don't recognize what that is. Okay, if key table key equals null, return false. Okay, where have I got an error? Oh, so that key there, that needs to be in a square bracket. My mistake. Just trying to identify where that error came from. All right, so if we want to make sure that the key has been used in the correct way, we need to make sure that we've recorded that value. So if they chosen a key that we do want, it's going to look like this. So it's a Boolean, and it's going to be in the key table, and it's going to be the key that we used. Okay, now let's detect something. Public static void. Okay, so this is obviously, we're now just checking to see if the button got pressed. We've just created all of the ideas that what happens if the button is detected, the idea that something can be detected, and now we're just recording whether or not it was detected. Okay, and very straightforward. Whoops. Key table again. So that key is going to be the result of whatever the state was. Okay, so either the state was either true or false. Okay, that should be everything that we've got again. So there's only a few things that are going in these classes. We've got the first thing that says we need to load our existing keyboard concepts. We need to set it out so that we can perform a check to see if a button is pressed, detect if it was, okay, and record the state. It either was pressed or it wasn't. Pretty much straightforward as that. Okay, now any game designer knows that the game has to have something for the user to start with, so like a setting. So, whatever game you choose, you're going to have a certain amount of life, you're going to have a certain amount of health, you're going to have a certain amount of, ammo, whatever it is you need to do. So whatever the user starts with is what we're going to set here in our settings. So we need to create it so that our user, which is the snake, obviously has to start with a head, okay, and it's going to be based on a timer. Okay, so what we're going to do is under our settings, we're going to use a set of name variables, and we'll get to those soon. Okay, so just moving down. All right, public class settings. Oops. Okay, so before we start that part, we're just going to do this part here. The enum keyword. Now, you don't have to know too much about these enums, but basically every key, as I said, has a concept, up, down, left, right, space, and everything like that. We are only concerned in this game about using the up, down, left, and right keys. Okay, so every time those keys are used, we want to initiate something. Okay, and we just have to point to something called the enum value. So I'm going to show you the code for that one. We've got public enum direction. And we need to simply have up, down, left, and right. Now, it doesn't matter too much if you, doesn't matter too much if you don't have, all of the stuff there that you really wanted to have or not. But I'll just, the enum value for this one is enum value equals 0. And then hopefully you can probably figure out that for left and right, we've got enum value equals 1, 2, and 3. Okay, so it's recording an integer 0, 1, 2, or 3 every time those keys get pressed for us. Okay, let's scroll down a little bit more now, and I've got public. Oops, a little bit further. Not sure why this one's not coming down for me. There we go, public class settings. Okay, so these are our factory settings. So as I said, your life, your health, that kind of stuff. Now in this game, these are the settings that we want to start our characters with. So we need a public static int again, and this one is going to be the width, and I want that to have get. Oops, set. Oops. Ooh. Now I'm going to just copy that because we're going to use that a few times in the next few minutes. Okay, and now we need public. Actually, you know what? I'm just going to copy that whole thing and we'll change a few of them. So I've got 1, 2, 3, 4, 5, 6, 7. Okay, now instead of width, I want one to be height, and I want speed, and I want score, points. And this next one, this is not an integer variable. This next one is a Boolean because this is going to indicate our game over. And we've still got get set, and we need just the one more. Oh, I had one there already. And I need one more. This is going to be the public status direction. So it's a direction data type. It's an important distinction there, which I'm just going to call direction, and I can get and set that value as well. So remember here, we're just creating concepts that we're going to use. We haven't created values for them yet. Kind of like when you when you first create variables. All right, the next one, we're going to have our actual starting values for these classes, for width, for height, and so forth. So in that field, we want public settings. Okay, and we're going to set our width to default at 16. Our height will also start at 16. Hopefully those that are realizing why I've got the same, it's because we've created a circle. The width and the height need to be the same in all directions. Okay, I'm going to create speed to be the same just because it looks nicer when we show our game. You want to make it faster or slower, you can go back and change that value later on and see how the game changes. I'm going to set my value to start at points 100. And I'm going to have game over set to false, so the game is not over. Oops, wrong value. There we go. And our first direction, so the starting movement of the snake is going to be down. Okay, but as I said, if you don't want to do that, you can create your own direction movement. It's pretty obvious once it happens. Why have I got an error? Because I spelled game over wrong. There we go. Okay, that's all of our previous default settings. I might just put in a comment there so you know what we just put in. Default settings for the game start. Okay, let's save that one. Yep, there's all of our code. Okay, so we've now set up our circle class, our input class, and our settings class, which means now we can actually go into the Snake game and we can start actually using those classes. So a lot of the stuff that you've just seen in these concepts is probably going to look a little bit strange. It's like, why are we doing this? Okay, now up until this point, you've been using things like message box dot show. Okay, now that's a piece of code that already exists. Okay, it was in our library. Now we can't, up until this point, use the word circle, and we can't use, game over and all that kind of stuff, because they weren't things that existed in the library until now. That's what we have just done. We've created some new pieces of code in the Visual Studio database, and you'll see them being used as we start to make our way now through this Snake project. Now, buckle up, because this one is a bit of a long one comparatively to the last few. So please follow carefully, and as always, pause, rewind, stop and start as you need to. Okay, so we're going to move, starting by creating our circles and our lists so that we can create them. So when we create the circle the first time, it's okay, but after we start adding more circles, we need to be able to store them somehow. So we're going to use a list to do that. All right, so private, let's jump right in, private list, and it's going to use the circle class that we created. And we're going to create that circle class, that circle list class called Snake. And it's going to be a new list of circles. All right, now we're going to create another entirely different circle. And if you know that we've created the snake here, hopefully you figured out that we actually need to create the food. So I'm going to use my circle concept again, and this one is going to be a food class, a circle class that we call food, and it's obviously the instantiation of a new circle class. All right, scroll down a little bit again. Okay, so that initialized component is always going to be there when you start our public class. The next thing we need to do is we need to create a new instance of settings. Okay, so we've used the thing that we created now. Okay, that's this one up here. We created our settings class. We're now creating a new version of that. All right, now if I just jump back here, you'll see, not that one, sorry, onto the Snake project. You'll see that I've got a timer installed. Now the timer is actually a really important concept for this Snake. It's because every piece of code is going to be executed based on a piece of time. Okay, we want it to keep running because it's a game, it's live. Okay, we need to be able to accept inputs, move the character around, and so forth. So the concept of the timer is really important built into this one. Okay, so we've created our settings and we've assigned them now. Let's now set the game speed. Okay, and start the timer. So get ready, we're starting the game. So our timer is called TMR Snake, and we're setting the interval to be equal to 1,000 divided by the settings speed that we previously assigned. Okay, so you can go ahead and change those speeds later on if you really want to. I would encourage you just to keep them as is while we're testing before you build it, because after that, then you can go and change them. All right, now every time the timer happens, every time the tick happens, so every time we have a tick, it's going to update the screen. Oh, why that started twice then. Okay, and every time we update, we're going to start. Okay, let's scroll down now. You can see it's got private void start game. Well, that's not a module that previously existed, so we will need to create that. We've created the module. We need to tell it to start. So the reason you have start game as a module is because once you finish the first game, you don't want to have to reload the form to restart the game. You just want to have a button that does all of that for you. So, but that then means that you've got to load that module when you load the form. So we're just going to start the game. Okay. Now, starting the game has quite a lot of content in it. So let's get onto that one. So on this, you can see I've got click game over, click enter. So when we start a game, let's just get rid of that. So you can see that that one there is LBL game over. So the first thing we're going to do is just hide that message that says the game is finished. So LBL.game over dot visible equals false. All right. Now let's go to reset the settings. Oops, that's a comment. Reset the settings. Now, you're probably wondering, didn't we just do that? Well, yeah, we did, okay, because I just did it up there. However, if the user starts the game mid-game, we now have to reset the settings again, okay? So we don't want to have to do that again. And so we're just going to go New Settings. Okay, now let's create our player. Now, this is where we're going to call in our class. So we created a circle. So let's create our circle player, our snake, based on our circle class. So the first thing we're going to do is we're going to do snake.clear. Cool. There we go. Now let's create our class circle, and let's give him a head. So the head of the snake is going to be an example or an instantiated version of the circle class. And it's going to have, if you recall over on our circle, it's got get and set properties. So this is where we're actually defining how our snake's going to be, or where it's going to be, sorry. Okay, so where it's going to load up is going to be at x equals 10 and y equals 5. Oh, well, that just happened. And y equals 5. Okay. And then we're going to add the head to it. Oh, I've just used the wrong brackets there. I was just wondering why that error was still there. Sorry. Just make sure you always get brackets right. They always look a little bit different, but it can make a big problem sometimes to C#. Okay, let's update the score. Obviously, when we start, the score should be set to nothing, but we've set it to be an integer concept so that we can add things to it. But in order to put it onto a screen, we need to convert it into a string. And we're going to put it onto the LBL score text field. And it's going to be what we have already assigned it to be. Settings dot score dot toString closing method. Okay, and finally, let's spawn some food. Oops, not spawn. Spawn some food. Okay, and we're going to load our generate food module. Now, what module was that? I hear you say. Well, we haven't done anything to it yet, but it's right there. Okay, so we've got to now put our code into the generate food module. Hopefully you probably figured out, well, we need to create another circle class or another instance of the circle class to do that. Okay, because that's what we're going to do now. We're going to load our generate food function. All right, first things we need to do, we need to find out how big the form is. So if the user loads up the form and it looks like this, well, we would need to do this new step, but we've actually going to allow it so that the user can expand or shrink that form to suit the size of their whole screen. So we can't rely on the screen being the same size for every single person. So we have to first take in the height and width of the form in order to allow us to be able to say, well, where does the food need to go? It's got to appear somewhere between this range, okay? But we can't do that unless we know how big the form is. So the first thing we need to do is take that data. So the max X position of the form is going to be the width of it, okay? So we're going to do pick canvas dot size dot width divided by settings dot width. Okay, now pick canvas. Where did I just get that from? If I head back to snake, you'll see this thing here, pick canvas. So it's referring to this blue area that I shaded. And of course, if you don't like blue, you can change it to whatever color you want later. Okay, now hopefully you can figure out then to get the height, it's simply the max Y pos with the height settings. Okay, let's do a save right now, make sure we're keeping on track with everything. All right, now we're going to find a random location create a food piece in a random location. Alright, so random is another class, but that's one that we didn't create. That's one that exists in the library, in the Visual Studio C# library. So we didn't need to create that. So fortunately for us, someone has gone ahead and done this type of work already in Visual Studio, just like they did with a whole bunch of other things like event arguments. Okay, so random is one that we use quite a lot, and I'm just going to call my random class random because I don't need more than one, and I need to create a new instance of it. All right. Now the food is going to be equal to a new circle class with these settings. So remembering that our circle has X and Y coordinates, okay, or get and set X and Y. So we're going to have a few things, but we want it to be random. So we can't put in get the random X and Y. We need to incorporate these things that we've just defined, our height and width. Okay, so X is going to be our random dot next between 0 and the max X pos. Yep. Okay, so it's starting anywhere between, so let's say our screen was 1,000 pixels wide. Okay, it's going to be somewhere between 0 and 1,000. X is going to be a value. You might choose 112 or 719. Now, it doesn't matter what it is, but it's going to choose a random X pos, and then it's going to do the same thing for the Y, because then we need to do a random Y position. Okay. And now we have no idea ever where that food pellet is going to appear, except it's going to appear somewhere on a random place on this pick canvas. Doesn't matter how big this pick canvas is. So when I play this form, it's going to go wide or short and all that kind of stuff. Okay, scrolling down, we're going to load our update screen module, which we've created. Now you probably saw that way up high somewhere and thought, I wonder what that is. Where do you get that code from? That's this piece of code right here. Okay, so we're going to scroll back down now, and I'm going to start. We're going to first check that we've got no games already running because we don't want to stop. Okay, so we've got if settings.gameOver. So be very careful now. I might even move this down a bit because I'm going to have quite a number of nested if conditions in this section. So be very careful where you have your brackets now. All right, so if settings for game over, that means basically if it's true. We want to do check if the enter key is pressed. Check if enter is pressed. So another if condition. Excuse me. We want to do input dot key pressed, and we're checking for the enter key. Okay, so now be careful of these brackets, watch where they're going. So if they did say restart, let's just restart the game. And there's another instance of me loading that start game module that I spoke about earlier. Okay, now if it wasn't game over, so if the game was already going, this thing would yield false, which means we now have a situation where we want to start. Okay, so the game is still going. Okay, so it's not game over, the game is still going. So let's now check that the user is inputting data. So they didn't put enter because they didn't try to start the game, so they must be doing up, down, left, or right. They're the only other things. If they choose other letters, well, we don't want anything to happen. We just want to make the player move every time we have an up, down, left, or right key. Okay, so this is going to be a bit tricky to understand because what we want to have is you've got to remember that whatever direction the snake is moving, we can go in one of 3 directions from that. But we can't do all 4. So even though I speak about up, down, left, and right, I can only ever do 3 of those based on what I was already doing. So for example, if the snake is moving up, I am allowed to move to the left, I'm allowed to move to the right, and I'm allowed to keep going up. But I cannot go down. Okay, so for those familiar with Snake, you cannot basically turn around and go back into yourself. If I was going across the screen from this side, I can keep going that direction, I can keep going down, I can move up, but I cannot turn back that way. So what I need to do is, if I'm already going left, I need to only allow myself to go up, down, or right. If I'm already going right, I only allow myself to go up, down, or left. Similarly, if I'm already going up, I can only go left, right, or down. So, up, left, or right. You don't want to go in the opposite direction to what you're facing. So, let's get this one going. So this is the user interaction. Okay, so I've got if input dot key pressed keys dot write. And my direction is not equal to left. Okay, so if the user pushes that they want to go to the right, is that the right on the screen? Yep, goes to the right, I cannot be also making sure that I'm already going to the left. I can't turn around and go back into myself. Okay, so we're going to have the same concept up and down. If you're going up, you don't want to be able to accept down. If you're going down, you don't want to be able to accept up. And if you're going to the left, you don't want to accept to the right. So we want to only allow it to do the other three. So we're going to say, it's got to be the wrong direction. So if they push right and we're already and we're not left, we want to allow them to turn to the right. So if they push the right arrow, and as long as they're not moving to the left, we're going to allow them to change to the right. Settings dot direction equals direction dot right. Okay, so the next one is basically the opposite of that. So if they choose the left and we're not going to the right, then we'll allow them. Oh, did I just change the word keys? That wasn't very smart. There we go. We want them to make sure that they can go to the left. Okay, and the third and fourth are pretty much the same again, but obviously if we want them to be able to go down, as long as they're not moving up, we'll allow them to go down. And if they push up, and as long as they're not going down, we want them to be able to go up. Okay, so be very careful about your matches up there. You've got them all in the right direction, they're matching in the right way, and all that sort of stuff. Okay, all right. So technically what I've been saying now is that we want them to go right, we want them to go left, up, down. Well, we haven't actually made them do that. We've just allowed that to happen. So we've approved the user's input, if you want to look at it that way. So we've said, yep, you pushed up and you weren't going down, so it's okay, we'll allow you to go up. But all we've done is say up is an acceptable move. So what we have to do now is actually then put the code in to make the player move in that direction. So a little bit more complicated because I now have to write in another code, oops, that's going to tell the player to move. So move player. Okay, and we're going to also, every time we move, we're going to redraw the canvas because we want the character to move every time he's moved. We don't want to just move to the left once. We want it to keep moving left until it then gets the instruction to move up, in which case it then moves up, and it keeps doing that as well. So in order to make it keep updating like that, you actually want this thing, pick canvas.invalidate. Okay, So you'll see that I've got the move player function there, and I will get to that soon, but I've still got a couple more just there. Okay, let's continue, guys. As I said before, this is a long one. We've still got a little bit to go, unfortunately. So let's keep going. This is pick canvas paint. So we're going to update the graphics now every time we do something. So this is a graphics object. I'm going to type in graphics, and I'm going to call it canvas. We're using a graphics class. All right, now, once again, I've got quite a number of nested if statements coming up, so again, please be careful of your brackets. So this one, we've got if not settings dot game over. So a couple of the times, remember, I try to tell you different ways of doing things. Well, you saw before if settings dot game over, well, that would yield false. Okay, this one we're trying to now have not false, which basically means true. All right. If it's still going though, like if that's so basically if it's not game over, then we want to keep drawing the snake. All right, and we've got for int I equals 0 as long as we haven't yet reached the length of the snake list, and just keep counting. Okay, and we need to draw our snake, so we're going to use a brush class. And we're going to call it snake color. Don't worry about that error, it just means we haven't used it yet. And this is our brush snake color. So so we've created the class called snake color. Now if I equals 0, okay, if I is double equal to 0, then you want snake color to be equal to black. Okay, and if it's not, we want the snake color to be equal to green. Should be brushes. Sorry about that. Okay, so what did we just do then? Basically, we've got a snake. It might be 5 blocks long, or 10, or 100. Doesn't matter what it is. If the first block or the first circle, okay, we want to make that black. And then if it's not the first circle, because we always start at 0, then it has to be green. So what does that mean? Well, it means the head is black and all the body or the tail is going to be green. Okay, so head is black. Oh, column header. Head is black and tail is green. All right, next one. We're actually still inside this then, sorry, so that's not the if condition. Once again, please focus on your brackets. Okay, so we're going to draw the snake now. So we haven't drawn it yet. All we've done is decided what color it's going to be. All right, don't forget, code requires you to be as specific as you possibly can. And we're going to draw it using an ellipse tool. Okay, because a circle is just an ellipse. It's just one that has an equal height and an equal horizontal. So what we want is canvas.fill ellipse. And these are the settings we want. So we want it to have whatever color was previously deemed, black or green. And it's going to be a new rectangle. Yep. With snake eye at position X. I might just push these on the next line to make it a bit easier to see. Snake eye position X equals to, the settings dot width, then snake eye position Y times, that's not equals, that's times. Settings dot height. Now we need to talk about the diameter. We've got settings dot width and settings dot height. semicolon after that. All right, so when you use the fill ellipse tool, it requires quite a number of different settings. So the first one is you needed to have a snake color, you needed to have the height and the width of the object, and the height and width for the diameter as well. So a bit complicated. Fortunately, we've got pretty much the same thing now for the next part, which is to draw the piece of food. Okay, so what I'm going to do is I'm just going to copy all of that. Okay, move down, draw the food. Okay, and we're going to change a couple of these settings. So in this situation, instead of snake color, we're going to just use a hard-coded red color. And instead of the snake at position I, it's going to be the food. Food. Okay, now the reason I tried to copy that then is because I wanted to focus on the difference here. You can probably see these eyes that don't appear in the food. Now that's because we actually need to have multiple painted circles for the snake. So not only are we painting one head, but you've got to paint all of the body parts after it. Whereas with the food, you only have to create the circle once. Now, with this, it doesn't matter how long the snake is. It might be 0, 1, or 10 circles long, but we still want it to have all of the settings. It doesn't matter which specific part of the body we're referring to. Okay, so I've got my settings there. Now, I'm just going to scroll back up because the next thing I need to do is put in an else, but you see that there's a lot of different brackets here. Now, I know where I have to put it, but I just wanted to emphasize why. So you can see I've got an if condition here. Now, if I scroll down, you can see where I'm keeping my cursor. That's where that if condition ends. And the cool thing about Visual Studio is that it's actually, as I highlighted over it, it's showing me which one I was talking about. So I know for certain that I am doing the else function to that if condition. Okay, so a very cool little helpful case tool there. Case for computer-aided software engineering. Okay, so this is what we're going to do here. We're going to update game over. Because obviously, if it failed that condition before, we must be in the end of game over. So we're going to say the game must be over. I'm going to give a simple variable called string that says something like that. Game over. And I'm going to put in this thing. I'll explain that in a second. Your final score is. Okay, and then I add on the settings. So that's not equals, that's plus. Settings score plus. Oops. Press enter to try again. Close brackets. Oh, I don't know why there was no bracket there. Semicolon. Okay, that little slash in the end, that's like a carriage return. So that'll just send it to the next line. So game over, your final score is plus the score, whatever that was, what was currently being recorded, press enter to try again. And then we've got to turn that actual label back on again. Otherwise, it's just going to change what's on it, but we won't be able to see it. So LBR game over.text equals what we just put in game over. Like I could have just done that equals all of that, but sometimes it makes it easier to update some keywords. And let's turn it on. Visible equals true. Okay. So there's a few in that one. Let's scroll down now. We're going to get to our move player function. Obviously, guys, if you're getting a little bit tired, we're pushing 40 minutes now, so take a break by all means. You can always watch these and do these over several lessons and several days. Okay, so this is our move player. All right, in this one, we're going to have a loop within a loop. Okay, most important for parts of the 2D array concept. So for int I equals 0, oops, not 0, for the snake count, -1. Now that -1 comes in quite a lot when you are talking about things that you don't want to go right to the end, because if you don't have that -1, it'll go over one more time. Okay. I greater than 0, and we're going to start at the end. Okay, for int I equals the snake count minus 1, snake dot count, sorry, minus 1, I is greater than or equal to 0. All right, let's move the head first. Hopefully you realize that we're going to move the head and then we're going to make the snake follow all of those parts of it. So we've got moving the head first. If I is equal to 0. Okay, being careful with your brackets once again. Okay, so let's do it. Let's do our first test. So if we go right up to the top of this previous stuff, we're going to recall these things now. That if it's right, then we can't go left. If it's left, then we can't go right. If it's up, then we can't go down, and all that kind of stuff. So we need to do a little verification now just to check some of those things. So I'm going to put in a couple of comments, and I'm going to use a case where we could use this a lot of different ways. I'm just choosing a case where because it's not something I show you very often, but it can be helpful to show you how it can be used effectively. Because often when you do your major project, you want to know, and so I like to show you different things. Okay, so case to determine the constant movement. So we want if going right, continue right. And then obviously if going left, continue left. If going up, continue up. If going down, continue down. We're doing another little verification just to check all that stuff for us. So here's how I'm going to write the switch statement or the case structure. It does occur in the course specifications. It's called a case where. They don't use the word switch in pseudocode. They use case, but in C# they use switch and then case. But it does work pretty much the same way. So we're going to do switch, and we're going to check on the settings, direction, parameter. Okay, and inside that. So the first one is the case where direction dot right. So if they're going right, we want it to have snake. Oops, Sankey apparently. Snake dot x plus plus. Okay, so if they were moving to the right, you're going to change their x position by increasing it. So to move it one more. Okay. And then we're just going to break out of that case. Cool. All right, now let's do the next one. If they're going left, we do have to change their x position again, but we have to go in the opposite direction. So I'm going to do x minus minus. Okay, why am I getting those zeros? Oh, I'm using the wrong thing. Use a semicolon there, guys. Use a colon, not a semicolon. Okay, next one, we need two more, obviously for the up and the down. So I'm just going to add those in. Down, so I want case direction up. So if we're going up, we obviously want to change the y value. And if we're going down, we want to change the y value by the minus. Okay, so that's all those ones there. Let's just do another check and make sure we've got our value of our canvas still correct, because it's quite possible now that at this point the user has changed the size of the field mid-game. Okay, they pushed a button. Well, let's just check the size of the field still the same. So get max, max size of the field. Or the canvas, it doesn't really matter. Sometimes I call it field. Okay, and we're going to go int max x pos equals the pick canvas dot size dot width divided by settings dot width. Okay, and do the same thing to get the y value. So that's going to be the height. That's going to be the height, and it's not the x value, it's the y value. Okay, more complicated one now. Let's check our collision with things. So we don't want to crash into other objects. We've got to check that that's happening. So what we want to do is, if the user moves, imagine this is my little snake guy here, my little mouse. If the user moves from this side of the screen and hits that wall, well, in some games, you'll see that the snake actually ends and that's game over. What we want is we want to make it be a bit more generous to the user, and we want the mouse to go through the screen and then come back on this side again. So it actually, keeps going into a loop. If we just left the game on loop without touching it, the little snake would just keep moving back and forward across. By every time it hit that width, it would reappear on the other side again. Okay, and the same thing will happen if we go up and down. So if we keep going up, it'll reach off the top of that screen, then it will reappear back up at this point again. Okay, so that's why I just got you to check those sizes of those widths again. Okay, so let's do a detection. Detect a collision. Let's just say possible collision with a wall. And we're going to have some more if conditions. So if snake I dot x is less than 0, we want to move the snake at position I to be on the other side of it. So, moved all the way to the end of the screen. So it's now 0. Okay, so we want to set it to be the size of the width of the form. So it automatically respawns on this side again. Okay, so that's going to be equal to max x pos. Okay, now we're going to have, oops, I won't do that. We got else if we want to have snake I dot x is, oops, not x, sorry, y is less than 0. So they've gone all the way down, sorry, above the screen now, because that's where 0 is. And we want snake at position I dot x to be equal to, hopefully you guessed it, max y pos. Okay, so the height of the screen is actually, it starts at 0 up at this point here, and it then goes down. So let's say it was 100 high, this point here would be 100. So when it gets to 0, so because we've been moving up, as soon as it gets to 0, it automatically becomes 100 so that it can keep moving up this way now. Else if, now we're going to do the other way. If it goes down, we want it to reappear back up the top, and if it goes off the width of the screen, we want it to reappear back on the beginning side of it. Okay, so we've got else if snake x pos, oh sorry, that's not right, snake I position it, I dot x, there we go, is greater than max x pos, so it's greater than the width of the screen. We want the position to be 0. Good. Finally, our last one, else if snake index position I dot y is greater than max y position, snake I dot y equals max y pos. Oh, sorry, equals 0. I'm getting tired. Okay, else if. Good. So that's detecting a collision with a wall. Now we need to detect a collision with ourselves. So this is where we will have game over. So if we crash into our own body, because the snake thing is so long, then we're going to die. We're going to run out of bullets. So this is our next detection. Detect collision with body. Okay, so this one is going to be for int j equals 1. Now I can't use I because I've actually still got that part of process being used up here. So I can't test the I anymore. So when you're testing a loop within a loop, the syntax is usually to use I first and then J. If you had to do a loop within a loop, you probably guessed that the one after that you'd choose would be K. Okay, so as long as it's less than the length of the snake, snake.count, we want to keep testing it after that. Okay, for int j equals 1. All right. If the snake at the position of I dot x is now equal to the position of j. So what is that going to mean? So we're actually just going to say if my x and y positions equal to of the head, or any body part really, are equal to the value of the x and y positions of any other body part. So it doesn't matter what combination of body parts have crashed into each other. If any two of them have the same x and y values, they have now crashed into each other because they can't. Two of the same circles can't occupy the same space. So what we're doing is we're basically saying if the x position and the y position of the snake with the I value and the snake with the j value body parts are the same, then we know that we must have actually crashed into each other. Okay. Oh, how have I just done that? That should just be an x. Dot x. There we go. So if snake I dot x is equal to snake j dot x and snake I dot y is equal to snake y dot y, then sometimes the auto thing on this is just a little strange. Then we're going to load up our snake die function. That's one of the last functions, but we have not yet coded that one. Why is that one giving me an error? I haven't got the brackets around my condition. Okay, if snake dies. Okay, now similarly, for if we've crashed into each other, we can do the same concept to see if we've eaten the food, because we basically want to say that if the piece of the head of the snake, so the one at position 0, is equal to the position of wherever the food is, then we've eaten the food. Okay, so let's move to the next one. I've got detect collision with food. Okay, so I've got if snake position 0 dot x is equal to the food position, or the x position of the food, and the snake head, so 0, the y position is equal to the y position of the food, then I know that I've got the food. So if the snake head and the food position had the exact same x and y coordinate, I've eaten the food, which means I can load my snake eat module. And that's another module we nearly to, but haven't finished coding just yet. Okay, after this one, we're now going to need an else. So this is the end of the if I equals 0. So I've just got a simple else after that says this, because it's basically saying all of that was just to check for the head first. Now we need to just make sure that it's covering the rest of the body with us. So we're just going to make it so that everything is moved one to the extra of what the previous one was. So let's do move body, and we're going to have snake I dot x. So the x position of whatever value we're up to is going to be equal to 1 less than it was before. Next, I'll just copy that because I'm going to put the y in as well. Okay, so Basically, what you want to do is you want to make it so that the previous body part is now the original body part. You're just changing the locations of each one of those. Okay, next one. All right, so we're nearly there. Next one is if a key is pressed, activate the input function. It's designed to work if any button is pressed, but will load the correct operation for each particular button. Okay, so if we've got on the form, we've pushed a button on there. So any key has been pushed down. We're going to just accept that key and tell it to check all of our previous references to make sure it's going to execute whatever we've told it to based on those specific keys. So we're going to change it so that our state first is that, yeah, we accepted a key, we heard it, or it did work. So our change state is equal to true. Okay? We felt a key push down. Yep, that was pretty much it. And when the key goes up, we can't feel a key anymore. So our change state is going to be false. We want our key to not be telling it, our program to not be telling us to use keys anymore. Okay, here's our last two modules, snake eat and snake die. So every time we eat, we need to make our body a little bit longer. So we're going to make the length increase by 1. Okay, so a very straightforward concept, but a little bit harder to execute. So once again, we need to create another circle to add on to our body. So every time we increase the length of the body from 0 to 1 to 2 to 3 to 105, we have to create another instance of a circle class. So I'm going to create that now, circle, and we'll just call it circle because we're inside a different module. Call it a circle class. And inside that module is going to be x equals the snake, and we're going to put it on the end of the snake. Snake count minus 1 dot x. Oh, that just did that. Y equals, we'll just do pretty much the same thing. Snake count y. Okay, add a colon after that one. Right, so I've created my new circle and I need to add it to my snake. Oops. Circle, close. Oh, that's capital. So I've added my new circle to my snake. It's getting bigger. Okay, let's update the score because we've got some points. Let's update the score. We've got settings.score plus equals settings.points. Let's show our score. LBL score.text equals settings.score.toString. Don't forget it's an integer concept, which means we need to convert it to a string so that we can see it. And finally, let's generate another food. Okay, so we want to generate or load our generate food module. That's the one way up here we've done ages ago. There it is there, generate food. So it's going to rerun that whole code, put another block of cheese, whatever the snake likes to eat, somewhere else in the game. Okay, generate food. Now we've got to die. So if the snake dies, the user died, it's game over. We are going to make it so that game over is true. So settings.gameover equals true. Game's finished. Okay. Okay, so we're about ready to test. We're just going to go and do a quick once over. I've got my program should now load everything that we've got, unless I've got an error. Let's just have a look. We've got snake and oh, my little character's going off the screen. So it's working sort of, but I've got my up and down key not quite working. Okay, so my up and down seems to be wrong. If I've got the up and down key wrong, that to me suggests that we've put probably in the wrong parameter, somewhere to do with going off the wall, and I cannot see anything wrong with that one, although I can see something wrong here. So when we're going up, we don't want to keep making the Y value go up. Okay, so well done if you picked that one up. Now, the top of the screen is actually 0. Okay, so if we keep going up, we're actually going to go above the screen more. So that one actually should be a minus, and the down should actually be Y plus. Now, that probably seems a bit confusing. You think Y going up would mean you're going up, not down. But Y is actually from 0 down to, let's say, 100. So by going from 10 to 20 to 30, you're actually moving down because you're going from 0 to 100 or 0 to 1,000 or wherever it is you want to go from that point forward. Okay, so I'll just try to rerun that code, and hopefully we haven't got any other errors now. Just load up my GameKeeper project. You can see my snake is now cycling through from top to bottom. If I choose the right arrow, he now moves from right to left, and it then respawns on the top of this side each time. As I start to control the character using my arrow keys, you'll see that my score is not only increasing, but the length of my tail is. The tail is also a different color, and the game over has occurred as well. So I'll just hit enter, and then it's reloaded that start game module now, so that we could keep replaying. I'm going to stop that, and I'm just going to show you the whole code all over again, just for this main project, just so you get that final send off. Okay, so I've got my my circle class and the list of circles created. That's how I was able to use the brackets I, so that I'm referring to each individual body part. Then I've loaded up my timer settings with various control parameters. I've created the concept of my created the values for my circle, and I'm creating the idea that I have to load the function food, which then puts the food in a random position based on the height and width of the form. I didn't show you that you can actually stretch the form, but you can just test that yourself. Every time I need to do something, I need to update the screen. So I wrote a function called update screen, which will make it so that we can go up, down, and left and right, and it will accept the input as long as we're going in the right direction. So, as I said, if you try to push right and you happen to be going left, it's not going to let you do it. Okay, but if you push right and you're going any of the other 3 directions, it will then allow you to turn right. So every time we do that, we've got to move and update the screen. If that happens, we want to make it so that our character or our snake has the actual color scheme. So I've got a brush that represents black for the head and green for the tails, and this draws my snake on the screen and updates it each time. Because I've got the update and the invalidate listed up top here. Okay, so please make sure you're verifying all your code. As always, stop and pause as needed. Then we've got string and game over. If we lose the game, I've got moving the player so that I'm moving just the head around. I'm testing, if it's right, I want to keep going to the right. If it's left, I want to keep going to the left. So the idea is you don't have to keep pushing right to make the character go right, or you don't have to hold it down. You just change the setting. Change it so it's moving to the left. Okay, then I'll just keep doing that until it's told to do otherwise. Okay, change it so it keeps going up. So it just keeps doing that until it's told to do otherwise. If it goes off the screen, then we want to reset it so that it goes back to the other side of the screen. And we want to check to see if we're having a detection with the body, with the food, and we need to update and move the body with us each time. We're also going to check that we've got keys being pressed and not held and then released again as well. And we need to eat a piece of food and have that added to our tail in order for that code to come on as well. Okay, guys, so I hope you had fun with this one, because it will take you a while, but it is fun to be able to play an actual game when you've actually completed it. Good luck for that. Don't forget, this can take a while to get through. If you take a couple of hours to complete this task, that's more than fine. Good luck, and I hope you enjoyed the GameKeeper projects.